Want me to start now? Okay.
Parte tú.
Yo comienzo, ¿sí?
Sí.
Muy buenas tardes a todos, espero que estén muy bien. En nombre de la Pontificia Universidad Católica de Valparaíso, en específico de la Escuela de Ingeniería en Construcción, darle la más cordial bienvenida a nuestro ciclo de webinar sobre el tema de la madera, agradeciendo, por cierto, además de la universidad, a todas las asociaciones que nos apoyan en el desarrollo de difundir temas de la madera y vinculados, obviamente, todo lo que son estructuras de transporte. Hago mención a SEC, a Soft Export Council, por cierto, y también a nuestro Consejo de la Madera, aplicado a infraestructura vial, SIPMA, y a las asociaciones de puentes y APMAS y APSE, capítulo chileno. El día de hoy vamos a tener la oportunidad de revisar y discutir acerca de lo que es la infraestructura de maderas en muelles, una revisión bastante ampliada, con el doctor y profesor Daniel Dolan. Quiero darle la palabra para comenzar a Enrique Escobar. Enrique, por favor.
¿Se escucha mi gloriosa voz? ¿Ahí sí?
Ahí sí, ahí se escucha bien.
Ya. Quiero saludarlos en nombre del Software Export Council, la Asociación de Madereros de Estados Unidos. Y quisiera agradecer a J.D. Dolan, amigo de larga data. Jan es uno de los ingenieros más brillantes que conozco en Estados Unidos en este ámbito. Él trabaja en Washington State, en la Universidad de Washington, en Pullman, Washington State University. Y yo quisiera señalar que estamos muy orgullosos de trabajar con la universidad. Tengo entendido que han obtenido algunos premios los alumnos recientemente. Hubo una ingeniera, la mujer ingeniero fue condecorada, de acuerdo a lo que sea el Mercurio de Santiago hoy día. Tuvieron algunos premios ustedes a nivel nacional, no sé si estaban informados, pero salió acá en las noticias. Y lo otro que quería señalar es que estamos completando este ciclo la próxima semana con una presentación del Pacific Lumber Inspection Bureau. Tiare, quisiera saber si se conectó un señor John de Visier, ¿entró recientemente? Yo lo puedo ver acá en el chat, sí. Y bueno, el tema de infraestructura en madera es para muelles, es algo que es parte de la misión del Ministerio de Obras Públicas, con quien tenemos una alianza. Aún estamos a la espera de recibir una respuesta del Ministerio en torno a lo que es el uso de la madera en puentes, que enviamos una propuesta y como Software Export Council estamos esperando la respuesta del Ministerio para poder seguir adelante. Pero para la división de obras portuarias lo que se presenta hoy es fundamental, porque también han habido problemas con los muelles en Chile que se deterioran. El pino radiata es muy débil y requiere una carga de 40 kilos por metro cúbico de CCA, eso se cambió recientemente, pero es una carga tremenda, de cromo cobre arsénico. Y vamos cada vez hacia materiales más, por así decirlo, amigables con el medio ambiente. Entonces, sin más, quisiera dar la bienvenida a J.D. Dolan, que nos acompaña esta mañana, esta tarde, y saludar a algunos amigos que nos acompañan desde Estados Unidos. Veo, está desde Atlanta el señor Lon Cyber, que nos acompaña esta tarde. Y bueno, tenemos una gran cantidad de asistentes que estoy viendo ingresan cada vez más. El señor Dan de Visier está del Pacific Lumber Inspection Bureau, que nos va a mostrar la próxima semana su presentación en torno al rotulado de productos de madera, lo cual es muy importante porque en Chile hay un decreto que es una barrera no arancelaria que establece que se pueden rotular los productos de madera en Chile sin certificación, los productos estructurales. Y eso es un riesgo porque los productos estructurales de madera de ello depende la vida de las personas, sobre todo en un país sísmico. La empresa CMPC se certifica. Yo estuve viendo la página web, tiene establecido quién lo audita desde el exterior y le entrega la facultad de graduar su madera mecánicamente, pero no conozco ninguna otra empresa que lo haga en Chile. Sin más, y habiendo anunciado lo que vamos a hacer el próximo jueves, quiero dejar con ustedes al amigo Dan Roland, que dicho sea de paso, está casado con una magnífica señora chilena y fue uno de los grandes logros de la alianza entre Washington State University y la Universidad de Concepción. Salió un tremendo matrimonio. Así que, welcome Dan, I'm giving the welcome remarks. I'm talking about your wonderful wife, Loreto, the wonderful marriage that you put together after your internship at Universidad de Concepción a few years ago when my hair was a little bit darker. So, welcome, and the audience is all yours.
Thank you. So I'm going to apologize. Lo siento. Pero mi español es tan pobre que hable en inglés. Sí, soy gringo. Oh, I'll have to continue, or else you definitely will not understand me in English. So Enrique asked me to kind of talk about use of timber in transportation structures, especially in piers and wharfs, and historically how we've done things in the United States. It's not my top specialty, but I've done some work in it. We've done some work for the Navy, US Navy, on developing some new materials for them as well in our labs. But timber has been used for centuries in piers and wharfs all over the world. This is one of the piers in Seattle that I often go over to visit. The uses include the decking for docks, wharfs, and piers, the superstructure, the actual beams and everything supporting the decking, all the way to the pilings themselves. There are some historical problems with using timber in marine environments. Decay due to marine borers, where this is one of the animals, but it ends up making the pier, essentially the piling, nothing but a sponge with a bunch of holes in it, honeycomb. And fungi and other also attack it. These are historical, so people have worked on ways to combat that decay. And there are historical solutions that have been there. First one out was really creosote, where you preservative treat it with creosote and work through the pentachlorophenol. I've worked and designed a couple of bridges using pentachlorophenol. It's in the United States, it's restricted to non-contact applications because of carcinogenic worries. CCA, chromium copper arsenate, is another one. Typically the green colored timbers that you see in things. And all of these end up with heavy metals that are now very much considered a pollutant for the surrounding water. And so back better than a decade ago, about 15 years ago, the Department of Naval Research awarded a project to our laboratory to try and develop new composites to get rid of the heavy metal issue, improve longevity of piers and wharfs, and try and improve things. Timber is still used in piers and wharfs. and it's primarily due to cost. Fairly easy to construct. The contractors are familiar with the material and can construct it with relative minimal training of personnel. And it's relatively easy to repair. You remove pieces and replace them if necessary. We've also come up with some jacketing options to jacket and grout inject or use fiber wraps, because pulling piers is a little more, pilings is a little more difficult due to the cost of removing the superstructure first to be able to do that. So carbon wraps, there are a number of companies that have them, steel jackets that are grout injected, plastic tubes that are grout injected. There's a lot of those type of repairs out there. They extend the life. They don't make it completely last indefinitely. We've also used a lot of timber in the retaining walls and bulkheads around marine areas. Things like this are very common. Shorelines, and to protect shoreline from erosion and wave erosion, and provide walkways and places where boats and ships can dock. Typically entail some pilings backed by the timber wall with whalers holding them in place, or combination of steel, sheet pile, and timber. There's a lot of different combinations that are there. Again, until recently, most of this was preservative treated. The problem with a lot of preservative treatment is penetration. Depending on the species, it's very difficult to actually get the chemicals into the wood. Sapwoods are always easy, but when you start getting to the inner part of the tree, the older material, it's very difficult in most species to effectively get the chemicals into the timber to make it preservative. And so you end up having a shell on the outside of a few millimeters thickness, and then you have a core that's untreated that end up having the same problems as if it were the whole thing was untreated. This is a combination of timber piles and whalers with sheet metal or sheet pile backing on them, coming into a industrial area for along a wharf. So what happened in our research facility, we developed this wood plastic composite, and we looked at getting it strong and stiff in the longitudinal ways, directions similar to what timber is in the parallel to grain versus perpendicular to grain. And that comes through in a special patented dye that a couple of companies use, but it's a wood plastic composite. It uses recycled plastic or can. It's depending on the financial cost of recycled feedstock stream. That's always comes down to money, to whether you're going to use new or virgin materials versus, unless there's tax incentives for it. But this is a fairly heavy composite that's then encased on the outside with another plastic material. In this case, it's shown with PVC, but there are other materials that we can co-extrude and have a cap on the outside. And this had turned out very successful. The Navy put us under some pretty high pressures, requirements. First, it had to be designed for a minimum of a 3-meter span. And this is an extruded, continuous extruded piece. So the length is whatever you want it to be. But it has to have a concentrated, be able to sustain a concentrated load at the center of the span of about 8.6 metric tons, distributed over an area of about 10 centimeters for distribution of that load. And that's because of the munitions that the Navy puts out on docks and the equipment for moving the material around, fork trucks and things like that, and the loads that they have to sustain, and making it to where you don't have a continuous wall, you get by with using pilings to make things work. And then if you have munitions out on a dock, you really don't want to have fire spread or additional fuels coming from the product that it's sitting on. And so we had to have a class 5 fire ignition and spread ratings because of the munitions. And so a lot of tests had to be done around formulations of especially the cap layer of this material in order to make the fire, to meet the fire requirements of the Navy. We did also a couple of demonstration projects with this product for the decking on this bridge over in Montana. It's been used in a couple of different places. It installs quickly, normal construction tools for clips to hold it in place. Nothing really difficult about assembly. And it's now being used for Navy piers. The Annapolis Academy Pier is all being built out of this. The parts of the ferry dock and the Puget Sound are being built with this material because it removes all the heavy metals. It provides for longevity because very few animals, whether they're insects, borers, or anything else, will consume it. And so the longevity should be pretty good. So this is another one of the docks in the Seattle area that has this product is starting to be implemented on with time. And these are some of the first places that they've been put in. The pilings and whalers for where the ferry comes in to push up against, the pressure walls and the rub panels that the ferry pushes against. And so it has a fairly good wear ability, but it's using the waste products from the wood manufacturer for lumber and other forest products. And it was originally designed to be able to be manufactured with recycled plastics, but virgin plastics work as well. But that's so that's why they came through our lab to try and it was developed. We developed it over a period of about 8 years with the Department of Navy to come up with it. I would like to now transition into other applications where timber has been used and is continually used in transportation areas. Wood has been used in transportation infrastructure since the settling of, before the settling of the Americas. Covered bridges like the Town Lattice Truss bridge that you see here, or an arch bridge in the red one, were done. The Department of Transportation for Vermont has had us do some tension testing on remove certain segments of bridges that are over 110 years old because they had to load rate their bridges. And so they gave us a sampling that we did tension tests on. And we actually broke our testing machine on the first one because we underestimated what we thought the strength actually would be. It ended up that we got as high as close to a 60,000 psi tensile strength. Modern bridges. This is the entrance to Mount Rushmore. It's a glulam arch bridge with timber deck on it. It's been there for, boy, since I was a kid. And as long as you maintain these structures, they'll last a long time. Any structure, I don't care if it's concrete, steel, timber, or whatever, if you don't maintain them, they're not going to last. You have to maintain the roadways, you have to maintain and inspect the bridge, you have to look for corrosion in the connections and decay of materials, and that's part of having any structure. You can look at the recent collapse of a building in Florida that everybody is aware of. That comes from maintenance problems more than anything, and not willing to pay the money to try and keep the system functioning and maintained. Politicians don't get reelected by maintaining things. They get reelected by putting new things out there, and we as the public pay the price. We need to start turning around and saying, anybody who owns a house knows you have to take care and maintain the house, empty the gutters and everything else. It's the same with any structure. And so you can make timber last a long time if, one, you control the water, and two, you maintain it over time. This is another one. This is one bridge that I really like in West Virginia. It's in the New River Valley area. It's a beautiful arch bridge that I used to go in with the Boy Scouts. Often we go around there. It was when I lived in Virginia. It was they're beautiful bridges, and they're beautiful. The material is warm to the feel as you look at timber. Timber continues to be used for vehicular bridges and for several reasons. I have a former student that she works for the Federal Highways in Vancouver, Washington, and she graduated like 5 years ago. She's been on the design for at least 6 bridges of timber during that time. And some of the reasons why they're used is cost, accelerated construction. You can put it and panelize it and construct a lot of it off to the side. You don't have to shut down as much. Possible use of the original foundation and superstructure, ease of repair. And while I was in Chile, living in Chile the first time in 2008, working with Mario Giuliano and Peter Deckent, we went through and designed a couple of bridge decks that allowed the Department of Transportation, Ministry of Transportation there, to be able to replace the decks on some of the secondary highways. Yes, it had to be imported because of the size of timber we were using, 2x12 nominal, which is larger than the average manufactured in Chile right at this time. But they didn't have to rework the foundations. They didn't have to get into the waterway, which would be very expensive in this country. We are not really allowed to work in the waterway of rivers very much because of the environmental issues. But they kept all the superstructure. The only thing they had to do is remove the concrete deck, put a lighter wood deck on, and they were able to maintain the load ratings for those bridges and everything else with a lot less cost than total replacement of the bridge. And so that's one of the reasons I've been trying to get the people in Chile to look at timber deck bridges in their secondary highways. I think it would, if they maintain them and they can design them properly, they would be a solution. A lot of our Forest Service highways in our country, like this one, are standard glulam bridges that are set up across short spans. and with a lot of uses like that. This is a glulam deck going in on top of steel girders with clips. So you put in panel by panel, it goes in rather quickly, lay out the deck rather quickly, probably replace most of one deck in about 2 days worth of work and have it done. Be able to put up the railings on the side if they were pre-assembled and ready to assemble. You'd probably put those up in a day and you'd be done with that deck of that bridge, except for the wear surface, usually an asphalt wear surface put over the top. So they can also look at them. This is a bridge that's been put up in the eastern United States, but it was set up because they could do accelerated construction and build that bridge off to the side, lift it in with a crane and place it. So most of it could be constructed off-site, which is a major trend in construction in North America. Off-site construction to accelerate the cost of the rate of construction, reduce construction financing, and reduce interference of the roadways in terms of transportation structures. Another glulam truss bridge that's being assembled off-site, but it can be lifted in as an entire segment, put into place, and change things around quickly. You don't have to shut down the road traffic as long. And this one is being built in place, but they're putting in the main side town lattice trusses for the structure stiffness and strength. Another one that's the total bridge being lifted in as a unit. So we end up having a number of different systems. Glulam, I think, still is one of the most used. Stress laminated bridges is one of the bridges that we put into in Chile that we designed there. Yes, it needs to be tensioned every 5 to 6 years with a hydraulic system to bring the compression back up on the deck, but they're very effective. Trusses are common for longer spans because it's lightweight, can be assembled off-site and put into place easily. And then you can also put in a repair of nail laminated type decks. They're a little more difficult to design and they're not as efficient, but there's different ways you can do things. One of the large volume of timber in bridges is replacement of bridge decks for minimum reclosure of the bridge. In Montana, the DOT in Montana was doing it for a while. Federal Highways, Sarah says that they're continuing to do this on some of their less traveled bridges, just so that they don't have to redo foundations and they can the detour or long detours, so they don't want to shut down traffic for a long period of time. Concrete, you end up having to wait for it to cure and everything else, so it becomes more of a problem. The railways really made use of timber, and there's still a lot of timber trestles under active rail lines in this country. This is one of the bigger rail lines from back in the steam engine times, but they're still between here and Spokane. The rail line still has at least 5 wooden trestles on that line that I'm aware of. They're still quite frequently maintained within the rail system. This is a really large one. BNSF Railroad, but it was this was for a mine that they built this one. but it's accelerated construction. They come back and inspect it and repair individual members and not have to replace the entire trestle. We also use a lot of timber in non-structural, let's say minimal structural reasons. Most of the posts are wood due to lower cost, ease of instruction for guardrails, but more than that, there have been some collision tests that have been run on guardrails to show that those wooden blocks increase the energy dissipation and make the guardrail system safer for the occupants of the cars that are involved in the accident. In some of them, we end up drilling holes through at this point that makes them a maximum capacity to reduce the deceleration of the vehicle and improve the safety of the occupants of the car that's involved in the accident. So there's a couple of studies out there that show that energy dissipation of wood when it fractures like that is beneficial for safety. I thought I put one in that had the holes drilled, but I guess not. It's also an aesthetic view of things. When you along a golf course or something like that, they'll often put up wooden guardrails. Retaining walls, very common, used all over the United States, especially when they want to put vegetation as well. They'll plant vegetation in between these sometimes. But it's ease of use, ease of installation, ease of construction, no special training of skills to be able to use it. And yes, we use preservative treatment in all of those. I've been involved in 2 structures that used naturally decay resistant species. When you do that, you have to make sure that you're using the heartwood and not the sapwood to get that decay resistance, but you're also going to pay quite a bit higher price because those species are typically hardwoods, and they, well, Sitka, Alaska yellow spruce also is one that's not too bad, but they tend to be species that are not the typical lumber type species that you're using for that. And so they're more expensive. But they combine those between steel piles and wood as well. Fairly frequently used. Of course, railroads use these for a long time. There's the difference there between a concrete tie and a wooden tie. They're both used fairly often still in the United States. There's an awfully lot of wooden ties being used, where in Europe, concrete ties are pretty much the standard. Sound barriers. So around our highway systems, we often erect walls on the side to stop the sound of traffic from disturbing the residential areas. And that's very frequently the use of timber, preservative treated timber. And if the CCA and other, the quats and things like that, people sometimes worry about leaching. It's not as bad of a problem, especially if they were to re-dry, but I don't know of anybody but one company that re-dries preservative treated lumber. But the chemicals actually chemically bond with some of the cellulose inside the timber, and they're not as big of a leach problem. If you're going to use borates and then some of the salts, they will leach out, but they're also the same thing that you use. Borates are eyewash. There's a sound barrier for airport, and they can have designs to them. So what would be required to use more wood in transportation in Chile? First, you would need to write or update a design standard to include the timber options in your transportation standards. You would have to allow imported material for larger cross sections than usually are produced in Chilean sawmills, and develop a design methodology for bridge replacement wood decks on secondary highways. It was started back in 2008 when I was there the first time to live for a while when I was on a Fulbright fellowship. But I don't know that it was ever completed. No one has really told me that. And so if it was actually, we have a bridge design manual for this country that the Forest Products Lab put together. There was an effort to try and update it, but the main protagonist of that has retired. I think it would be a good thing to update it again by someone with newer blood than the rest of us old people like me. I only have another 8 months and I'm retiring. Work with the bridge contractor to determine what training, if any, might help them be more productive and profitable by working with timber. And develop some guidelines for designers and contractors to better understand the difference between working with steel, concrete, and timber. There are differences. There are similarities. Each material has its proper location, and each material for each project can be the ideal one if they are designed properly. You cannot design a timber bridge as if it were a steel bridge or a concrete bridge and expect it less. You need to control water. Your stiffness is different. And those kind of things need to be considered as you do that. Students get a break today. Incorporate the fact that lighter weight of wood decks might mitigate the required upgrade and repair of the existing superstructure when working with existing bridges. You could potentially use the superstructure there and only the deck and possibly walkways, if there are walkways, pedestrian walkways on it. You could potentially simply repaint the steel deck or steel superstructure and put a wood deck down. But you might at least avoid having to get in and redo foundations, which is really expensive when you get into bridges. Redoing abutments and piers out in the middle of the river is expensive. And so I just look at timber bridges as being one of the potential solutions to extend the government's budget for repair of roadways. And I think it could be a very effective one while utilizing materials that are local. The lighter weight of the decks will also reduce the seismic demand on the superstructure. And you can panelize it and put it in panels. You went to either stress lam or blue lam decks, you can put them in and panelize them off-site and lift them into place and accelerate the construction process. If you have a bad foundation, you have a bad foundation. There's not much you could do about it, but you might avoid tearing that whole pier out and be able to just deal with the timber, the top cap, repair that and put a lighter weight bridge on top and make it last another 40, 50 years. Develop design and construction guidelines for paving over of wood decks. You need to control the water. Now, when I was at Virginia Tech, we had a project through AASHTO and Federal Highways and Forest Products Lab that we were looking at the different layers that you could put between an asphalt wearing surface and a timber deck. And we ended up putting a report together to recommend what methodology, if it was a stress lam deck versus a glue lam panel deck, different adherent layer that polymer that you roll out over the top of the deck first before you put the asphalt down made a difference of up to 5 years wear life on that new wearing surface, simply by what you put in between the timber deck and the asphalt on top. Not all countries have timber manufactured in the species needed, i.e. density or the sizes required. Yes, that's true. However, the world market is removing that barrier. Chile exports a lot of product to the United States. Sometimes the United States should possibly export back. I know that some of the buildings built in the North mining regions had imported southern pine and or Douglas fir material to build those 6-story structures. From here, trade goes both ways. So this is a thing that I always end up preaching about when I'm talking in Chile. Single entities can't move significant change. You need to collaborate. You need to work with others and build an effort from multiple aspects in order to make really significant change. So build coalitions with people, of designers, of other researchers, of whoever it is around the country to build a groundswell of support to make change like this. It takes a group to get over big problems and make significant change. That's what I want to say. And I'm going to close with this. We're about to, this is a project I'm currently working on. I told my team that I would at least put one slide in for this. Next month, we start construction on a 10-story full-scale building to be tested on the earthquake table in San Diego. We will be doing the tests on that probably starting in March. And we'll go through for a while, then we're going to change over, and the Michigan Tech is going to change and put some special dampers in on the rocking walls and run it some tests. And then the Japanese are coming in and using the specimen. They're going to look at changing the post-tensioning system a bit. Then we're going to remove 3 floors, and Oregon State is going to do some tests on diaphragms and things on it before we tear it down. So that building will be under test for quite a few months after it's built, but we probably will start testing in March of 22. With that, I can try and answer any pregunta that you have.
Okay, thank you, Dan. Fantastic presentation. It's really, really nice to this overview of the different structures that compose the infrastructure. So it's really, really nice to see the different options that we have here in Chile and Latin America to incorporate the wood and the timber in the structures. So not only think about of building, also apply in the roads. No?
Well, in the building, I worked really hard when I was there this last sabbatical in 18 and 19, working on trying to get the light frame and mass timber buildings into the way. There's a space for timber in each one of those aspects. If it's designed properly, it functions well. And so I'll continue to fight the battle.
Yeah, you talk about, for example, the lightweight, and I think that is one of the advantage of the use of timber in the different structures, especially in our countries, that we have the problem of the earthquakes and this problem of the mass that you have to reduce for any kind of efforts. It's
That's very true.
important. Yeah, sure. And also, it's very interesting about you talk about of the different typologies that we can use, and that is one of the thing that we are looking for here in Chile. Not only use the timber in the deck, in the traditional bridges, also try to extend that idea for example, arch bridge, truss bridges. So in that way, what do you think the best typology that we can use, non-traditional typology of bridge that we can use the timber in
Well,
general?
well, arches and straight beams, glulam works really well. And you have a reasonably good glulam industry there. I've been in a number of the plants making glulam and around Santiago. But there's also, you could look at box beam bridges, either with glulam, stress lam, whichever way you want to look at it. Any of those can be formed. The performance, you can always get initial performance that'll work fine. The problem is longevity in my mind. And so you have to design your design such that it sheds water and doesn't trap water around the connections or things like that to improve the conditions for decay.
Yep.
Now, if you were up in the Yukon or somewhere like that, up in close to the Arctic Circle, where it's frozen most of the time, decay is not the issue because you need warm weather. But everywhere that I've lived in Chile or traveled in Chile, there's a lot of rain, except I haven't been to the Atacama yet, but I will. But southern Chile, from Bio going south, there's a lot of rain and it doesn't freeze very often. And so it's perfect conditions for decay. So what the design needs to do is control the water. And it's like, if you have a lot of rain, don't build your house with a flat roof. It's going to leak. You need to somehow look at the design itself so that it sheds the water effectively. And then you'll have a longer lasting bridge with lower maintenance costs.
Yeah, I think that one of the concern when we talk about for any engineer that, okay, we want to design and build in timber is durability, and absolutely agree. But I think that especially in the case of bridges, and Robert Martinez asked about this, the question is durability. And in the case of piles, for example, or piers that it's exposed to water directly, so the experience in United States, the use life of these kind of elements.
Well,
How much?
maybe Don can answer better than me on that one, but if you have the pier completely submerged in water, it lasts a long time. It's in the transition zone where it gets what we call the splash zone, where it gets water and then it's air and then water and air back and forth. That's where most of the decay ends up occurring. And the piers, like my father built a lot of bridges. He had a large bridge contracting firm in 5 different states he worked when I was growing up. And they put in a lot of timber piles underneath a concrete abutment or something on the wear surface. But the timber piles, they're still good because they're not exposed to air water change back and forth. And if you end up looking at our telephone and power poles that are timber, those are lasting 40, 50 years. But if you turn around and you want to look at a concrete bridge, the life expectancy of a concrete bridge when we were designing, 50 years is a long time. And they have to be maintained just like any other one during that 50 years. So it comes down to whether you want to maintain, pay for the maintenance. And everybody thinks that
concrete
and steel, you don't have to maintain. That's not true.
Yeah, absolutely. In our case, that we live very close to the sea, we can. It's very clear that concrete reinforcement of concrete is the corrosion is incredible. You know, it's
Yes.
You see all the all the constructions that it's very close to the sea, and it's incredible how it's cracking, and the corrosion of the rebars are impressive. You know, so you are absolutely right. The same in the case of the steel. So you remember the Golden Gate Bridge. So how they have to protect, and the treatment that they have to paint every day and every year.
Yeah. The Golden Gate Bridge has a crew that is continuously painting that bridge.
Yes.
Year round.
Yeah, that's right. So timber is part of that, especially in the connection. But I think that it's a good solution. And of course, if we put a good treatment of protection, we don't have really problem. In that way,
you could do also, you could use like the wood plastic composite in the part that region where you have that transition, and put the rest of it, because the wood plastic composite, you machine, cut, drill, everything the same as timber. And so you don't have to have special tools, special training, know how to weld or anything like that. You get the preservative treatment without heavy metals in that region that you need it the most. And then on the rest of it, you can have timber that's easy to maintain. You can put spray sealant on it. You can do all kinds of things to slow down Mother Nature. It doesn't matter what material you have, Mother Nature is going to win in the long run. Always.
Yeah.
Every material.
And that was my question. The ACB, the accelerate bridge construction, and the use of composite, it will be the future? What do you think about that? In bridge means, you know, in bridge structures.
We're seeing a transition now. I think there'll be even better composites developed in the near future. We're working on some, and I know of a couple other labs that are working on some to improve the wear surface, the hardness of the surface. So we're seeing on the ferry docks, when the ship comes in and it starts riding up and down on that wall, that it abrates it just like sandpaper. And so looking at improving that wear surface ability is something that people are trying. But the average part, the superstructure part of the bridge, if you can keep the water controlled, it'll last a long time. Timber, there are timber structures in Europe that are over 300 years old because they keep the water away from them. We have bridges in this country, they're covered bridges in the northeast of the country that are over 250 years old, and they're still being used by semi-trucks.
Yeah. That was incredible.
I would like to say...
Yeah,
sorry.
Enrique, adelante. Sí, adelante, Enrique.
Yo quisiera decir, what I would like to say is that there is a company called Acoya, and they have a process of wood acetylation. They have used wood, Radiata pine, they bring from Chile into the Netherlands, and they produce a highly resistant material that will last almost forever. There's a factory in Chile for facades of residences and commercial buildings. But the point is that these developments are very expensive. So in order to answer your question, and I'll resort to Spanish now, Existe tecnología para poder fabricar productos de madera modificada que son tremendamente eficientes desde el punto de vista técnico. El punto es que no se masifican por costo. Accoya es un excelente producto. Yo estoy colocando acá en el chat algunos ejemplos, pero no se vende porque es absolutamente carísimo. Y eso es una de las ventajas que tiene la madera, que como solución constructiva, siendo impregnada, es eficiente desde el punto de vista, ¿cómo decirlo?, de su precio. Que eso es muy, muy, muy importante también. Eso es lo que quería comentar, que en Chile existe una empresa que se llama Coya y tiene madera modificada. And Jan, the university he works at, have a very intense activity in the area of the so-called composite developments, which are hybrids between wood and other products that, in an effort to make wood last longer.
Yeah, but it's also, if you want to be more than just transportation, there are very few structures that are ever built that are solely a single material. And so you actually can look at I've got one PhD student, and there's two other master students that are looking at a combination of how steel and cross-laminated timber or glue lam or things like that, how to make that connectivity more efficient in construction, higher quality, and longer durability when they're in the environment. So those kind of developments will continue to come, but it's rare, really rare, that you have a single material for any structure.
Yeah, well, true. Well said. I believe that there is a question, someone who's talking, theft, replied that theft in Chile is a reality. Rose Vasquez said, and I'm taking the job of Matias at this point because he's the one who's supposed to answer the questions or lead that process. Bridge timber is expensive and of high quality, and therefore it is susceptible to theft. Hay robo en Chile. La madera en la infraestructura, la gente se la roba. Es un problema cultural que tenemos en Chile y hay que protegerla. Los paraderos, la gente la saca para utilizarla como leña o para venderla como vigas. Y es un problema cultural, pero también puede haber en eso protección por diseño. Esa sería mi respuesta. What they say, Dan, is that in Chile, wood can be stolen as components from a piece of engineering.
I've learned after living there enough times, things get stolen really easily, including out of my own yard. So
yeah.
It's just that happens here too. I can remember my father having to have security on construction sites. I mean, people would come up and steal the entire crane when they're from the job site. So it's not just Chile that has theft problems. That's a worldwide issue. That's humanity. But reasonable care, and depending on how it's actually constructed, you'd have to be pretty unique if you're going to steal parts of a bridge after it's assembled, I think.
Yeah, in Chile, it's good and copper, both maybe the two materials that normally be stolen. You know, it's
Yeah.
Yes.
Copper here, and especially copper. People will go into houses and just strip out the copper just to sell it. Yes.
Yeah.
Well, yeah.
Enrique. Oh, perdón, Enrique. Sí.
No, te quería decir que ese es un tema, el de los robos, pero es parte de lo que tenemos como país. Nosotros como SEC donamos un puente a la Municipalidad de Santiago, y el problema que tenemos en la Municipalidad de Santiago es dónde colocarlo. Yo había pensado el Parque Forestal, cerca de la Plaza Italia, imagínense cuánto podría durar, lo van a quemar. Entonces, la violencia, el robo, es todo un tema, pero bueno, espero que podamos ser más optimistas y creer que podemos construir un país mejor.
Sí, Enrique, solamente para complementar lo que nos escribía también Raúl Vázquez, comenta algo importante que es la inspección continua y el mantenimiento permanente para evitar accidentes. Yo creo que, bueno, es algo que hemos estado tratando en este ciclo y que es importante a la hora de estructuras, digamos, permanentes que nosotros debiésemos considerar en la infraestructura vial.
Sí, sí, yo quisiera señalar que, bueno, este ciclo de- de seminarios va un poco en esa dirección y que hay capacidades en Chile para hacer esto. E incluso se pueden traer muchas veces puentes armados modularmente desde Oregon. Hay compañías y esto son tecnologías modulares. Ese tipo de ese modelo de negocio lo tenemos y se puede hacer. Yo espero que podamos avanzar en esta materia. Ahora, respecto a los elementos marinos, en Chile hay una flora y una fauna marina que está investigada por la US Navy. Cuando en la embajada de Estados Unidos conocí gente de la Armada norteamericana, ellos tenían una caracterización de la flora y fauna del mar de Chile y los microorganismos que hay y cómo estos eh, animalitos pueden destruir la madera. Es parte de lo que me tocó conocer y tenemos una norma NSH 819 que establece cuáles son los criterios de preservación que hay que tener con la madera en muelles. ¿Ah? Son cada vez es muy difícil salir del CCA, del cromo cobre arsénico en esa área. CCA remains being the most prominent preservant when it comes to piers in Chile, despite the criticism that it faces worldwide because of, well, chromium, arsenic, and are not exactly, well, healthy materials if you eat them or breathe them. But that's the state of the art that we have here in Chile. We have two large companies. Tenemos dos compañías grandes, una es Coppers y la otra es Lonza, y ambas fabrican elementos de preservación, así que se puede hacer. Ahora, el punto es que la madera también tiene que tener una capacidad estructural que tenemos que certificarla y todo pasa por tener productos certificados y la voluntad del Ministerio de Obras Públicas de utilizar la madera, porque si no hay una voluntad política, no, esto no va, no se va a hacer. Pero parte del rol de la universidad es enseñar y transferir tecnología de modo tal de que podamos tener todo esto de mejor forma, con mejores ingenieros, mejores arquitectos. Días atrás en un chat yo dije que en Chile había mucha falencia en lo que es el uso de ingeniería en madera, ingeniería civil, y el señor se enojó conmigo, un gran ingeniero, sí, pero hay dos, tres. Tenemos Mario Wagner, tenemos dos o tres que están en las empresas mismas, pero de madera laminada, pero no hay mucho más. Así que yo confío que la universidad va en el camino correcto y que vamos a lograr transferir estas tecnologías.
Sí.
Matías, hay una señorita que está hablando, Bárbara
Sí,
Helwig.
eso mismo te iba a comentar. Hay un comentario de Bárbara quien nos plantea que efectivamente hay un problema de mantenimiento e inspección y pone un ejemplo de las tapas de las cámaras de alcantarilla que son robadas. Efectivamente, hay muchos elementos, digamos, que requieren una protección y no es solamente la madera. Enrique,
Sí.
en orden al tiempo, bueno, yo creo que podemos dejarlo hasta aquí. Dan, thank you very much for your time,
Thank
your
you.
excellent lecture. I think that you provide us a very nice overview about of timber and of course the structure. So thank you very much from our side.
This comment by Raul that just came through, hardwoods, most of our glulam is not made from hardwoods in our country. It's made from softwoods, and I agree. There's few glulam companies in Chile. There could be more, I believe, but the ones that I've seen, they were all using softwoods as well. I have not seen a hardwood glulam operation other than potentially in the northeast of the United States. So Hardwoods would be quite expensive, I agree.
No, but today Raúl Vázquez responde que hardwoods are scarce and expensive. ¿Qué maderas tenemos nosotros en Chile que puedan ser consideradas hardwood? Eucaliptus. ¿Ah? Pero para fabricar productos de ingeniería son maderas muy duras.
Yeah, but eucalyptus could be used for glue
Yeah,
lamp.
but if you have a glue lamp processing plant, it's easier to cut and drill radiata pine than it is to do so on eucalyptus. And the fact is that we have a huge swath of radiata pine for structural purposes.
I know. I was helping. I helped design out of Alco's headquarters, but they decided not to build it in mass timber quite so quickly in Concepcion. So
CMPC or Arauco?
Arauco.
Well, because the one who built it with CLT, CMPC. CMPC tiene las oficinas hechas con cross-laminated timber en Los Ángeles. Es un edificio precioso. Pero no falta. Tenemos las ganas. La madera es débil y de baja densidad. Por lo tanto, si no se preserva adecuadamente, el resultado es un desastre. Y hay que certificar no solamente el grado estructural, hay que certificar además el contenido del preservante. What we need in Chile is not only to certify the structural grade of lumber. That CMPC is the only one that is audited internationally in that regard.
I know that.
The others,
I know that. I wish that would change.
Las otras compañías dan una declaración propia, excepto para los grados visuales. Visual grading can be audited, but when it comes to mechanic grading, los grados mecánicos, no hay una adecuada certificación y una declaración del fabricante. Y lo otro, que es muy importante, es la cantidad de preservante y el tipo de preservante que tiene que estar certificado. They also have to certify the amount of preservant that you add to the wood, because sometimes they just paint it green. It's a light. It's also, not even a preservative. It's an ink, and people claim that it's a preserved wood. Treating wood for peers is extremely expensive, and it's a painstaking job, if that's the word in English. But we need to certify that.
Inforest trying to put a grading system into Chile as well.
Yeah, so did we at Corma. And we created but companies sometimes prefer a free ride. Las compañías a veces prefieren que no las molesten mucho y hacer las cosas como ellas quieren, particularmente las empresas pequeñas, porque esto es caro. Y esto, sí, que de esto dependen vidas humanas. There's lives depending on it. I mean, if you have a pier in the Pacific Ocean, in a seismic country, give me a moment. I mean, we need to be sure that it's well preserved and well designed with proper materials and certified. No. El gusano de la broma se llamaba en Ancud, el que se comió un muelle que se cayó con todo lo que había arriba. Y eso pasa. Así que, bueno, eso podemos seguir adelante. Y maybe we can have a deeper presentation from an entomologist who may speak about what we have in our seas besides salmon, and what kind of organism eat wood. ¿Cuáles son los pero ahí tenemos tema para otros webinars, Matías.
Así es, Enrique.
Dan Deviser, no sé si quiere decir algunas palabras. Está Dan. Don, are you there? Don Deviser, are you listening? You're going to be a speaker next week.
Yes. The speaker next week, I'll be participating, but the speaker next week will be our Director of Engineering or Technical Services, Henry Morris, and who's participating in this in this meeting as well. And I'm glad we got an invitation because we don't want to cover things that Dan covered today, but we'll probably expand on things, particularly as far as the development of design stresses in the US for dimension lumber timbers and glue laminated timbers. And so this has been very, very helpful for us. One thing I want to point out, a little interesting fact that Dan probably knows about this. When talking about piers, the city of Venice, Italy is built on Russian larch piers that were installed over 1,000 years ago or somewhere around there. And as long as, and just to reiterate what Dan said, as long as they are in an anaerobic situation where they're buried and kept in water, they usually do quite well. It's when you get in that zone Dan talked about where you get water and air exposure that problems can develop. But we're looking forward to again, giving some a presentation and expanding on Timber Bridges, at least the design methodologies that are used in the U.S. and are available, and give Chilean designers a background as to how we assign our stresses for dimension lumber, timbers, and glued laminated timbers.
Don, it would also, I think, if you could touch on the benefits of having stress grades from an engineer standpoint and performance standpoint would really be helpful.
Yeah. Again, sitting in on this meeting will really help us as far as areas where we want to concentrate next week. So thank you for the invitation.
Mm-hmm. Thank you, everyone. Matthias will give the closing remarks as the president of our recently created Council of Wood Infrastructure in Chile. I'm the executive director, and he is the one who calls the shots as president. And Matías, creo que estamos muy contentos porque tenemos gente de primer nivel, tanto en Chile como en el exterior, una significativa participación. No sé si tú quieres decir algo más antes de que cerremos.
No, simplemente, bueno, agradecer la participación. Ya, bueno, ya saben, tenemos un cierre de ciclo muy interesante la próxima semana. No olvidar que mantenemos mismo día, mismo horario para que no se pierdan la oportunidad. Y así como también como comité, como universidad, recordarles que a finales del mes de octubre vamos a tener la organización del tercer Congreso Internacional de Puentes, en el cual uno de los temas que será tratado es el tema de la madera. Ya la próxima semana les vamos a dar más información para que puedan participar.
Sí,
así que agradecer a todos.
Nos está auspiciando, ¿cómo se llama? CMPC. Hay otras empresas que probablemente van a participar, que se están uniendo al esfuerzo de SEC y de la Universidad Católica de Valparaíso. Hay algunas postulaciones que se enviaron de una fábrica de puentes de Oregon que va a presentar sobre puentes modulares de madera. Y también el Pacific Lumber Inspection Bureau creo que tiene una postulación también presentada para participar y mostrar las tecnologías que hay en el ámbito de rotulación. Ese proceso, también, Matías, se terminó, se aprobaron ya los...
sí, están aprobados. Están aprobados y a partir del 30 de septiembre se va a difundir el programa, que además incorpora otras temáticas vinculadas con puentes. Así que ahí también los vamos a dejar cordialmente invitados a participar. Bueno. Bien.
Perfecto. Gracias.
Enrique, Dan, thank you. Ha sido un placer y nos volvemos a encontrar el próximo jueves en el mismo horario.
Ahí les dejé la presentación. La presentación está en el chat, pueden bajarla y verla.
Exactamente.
Está en castellano.
Exactamente.
Está en castellano.
Nada.
Ok, thank you.
Chao.
Chao. Thank you, bye.